Okay, so trig identities. So in this video, we're going to look at two trig identities. Essentially, these are two little expressions to help us simplify certain equations that we could come across. So our first trig identity is if we have sine squared x plus cos squared x, that is always equal to 1. So whenever I have sine squared x plus cos squared x, that is always equal to 1. And that one in particular could be rearranged a little. So for instance, I could have sine squared x is equal to 1 minus cos squared x. So there I took away the cos squared x from both sides in order to get the sine squared x on its own. And same if I wanted the cos squared x on its own. So that's just something to keep in mind, that this one we can quite happily rearrange it into different forms in order to help us with our trig identities. The other one, which we don't really rearrange, normally we use it as is this one here, where we have tan x equals sine x over cos x. And so for nat 5, that is our second trig identity. If you go on to higher, you will come across more, but these are the only two we worry about for the time being. So what we're going to do, we're just going to jump straight into a question on how we use these trig identities. So look at this first one here. I've got simplify sine x, cos x, tan x. So the first thing we want to do is think, right, which one of my two identities am I going to be using? Most of the time you're only going to use one. However, there are a few occasions where you might need to use both. So I'd look at this expression, and the first thing I can see that jumps out to me is the fact we have this tan x here. The fact I've got that tan x means instantly I can use that tan x equals sine x over cos x. And I would write this down somewhere. I'd just write down my trig identity so I have it written down for me to use. So the first thing I want to do with that is I just want to swap out the tan x for that fraction. So I'm going to have the sine x. You know what? I'm just going to put a little times sign in between so I can just break it up a little bit. Times the sine x over cos x. So all I've done now is that I've just swapped out the tan x for that fraction. And then I've got at the bottom of this fraction, this is saying I'm dividing everything by the cos x. And I've got another cos x here. So what can happen is that those two are going to cancel each other out. So I now have left the sine x plus, sine x times the sine x. Because remember, if something entirely cancels out, it's a 1. So if it's on the bottom, that means it's just going to disappear the fraction. And when I've got two sine x's multiplied together, that is my sine squared x. And that is that expression simplified. So let's take a look at question 2. So here I've got 5 sine squared x plus 5 cos squared x. So the thing that jumps out to me is the fact that we have this sine squared x plus that cos squared x. So that instantly tells me that I'm going to be using this identity. And the fact it doesn't have the word tan, the fact it's not a fraction is another reason to make you go, oh, it's the sine squared x plus cos squared x one. So what we're going to do here, the first thing we're going to do, we're going to actually common factorize it because we need to get that sine squared x plus cos squared x on its own. So they have a common factor of 5. And inside the bracket is going to be our sine squared x and the cos squared x. And then I know that little expression there is the exact same as 1. So I change it to 1. And so my final answer, my simplified answer is 5. Okay, let's take a look at another question. So here I've got simplify sine x plus cos x all squared. So right now, that doesn't look like either of my trig identities. The fact there's no tan kind of gives me the hint I'm going to be using that sine squared x, cos squared x one, but I don't have that in front of me yet. So I need to just expand that first. So that's what I'm going to do. So what that means by having it squared, it means I've got two brackets of the same. So I'm going to break apart that first bracket and put the second bracket next to it. Ooh, I don't think I'm really going to quite fit that. I'll just squeeze it in here. Ooh, not quite. And then I'm going to start expanding it out. So sine x times sine x, that is going to be sine squared x. Sine x times cos x, that's just going to be plus sine x cos x. Then that cos x times the sine x, that's going to be plus cos x sine x. And then that cos x times that cos x will be plus cos x, cos squared x. So it's a bit squished there. So then look at it. There's my sine squared x. There's my cos squared x. So those two parts there are just going to be 1. And then look at my other two parts. It's a sine x cos x and a cos x sine x. Remember, we're multiplying, it can be any way round. So 3 times 2 and 2 times 3 still is 6 at the end of the day. So those two things are the exact same, even though it's been written the other way around. So I've got 2 lots of them. So that means I've got 2. I'm going to go for the sine x cos x. But I could have written 2 cos x sine x. Both would have been fine. Okay, question 4. So one thing that could sort of throw people off a bit with question 4 is the fact that we've got this cos squared x here. Some of you guys might at first think, oh, it's going to be my sine squared x plus cos squared x. It's not going to be exactly that. The thing you want to always focus on first is a tan. If there's a tan, try the tan identity. Now, it might look a little different there because it's the tan squared x. But remember, tan x is just sine x over cos x. So with that in mind, tan squared x would just be sine squared x over cos squared x. So that means that expression there, I can just swap out that tan squared x for that fraction. And I've got that cos squared x from before. Those are going to cancel out. So all I'm left with is sine squared x. Okay, so those are some questions where it's just simplified, but there's another way that these can be asked, and that is where it says show that. So this time, these can actually be quite nice questions because it kind of gives you a guide of where you are wanting to get your answer to. But the layout for these, there is one sort of like particular way to sort of lay it out to show that you're proving it. And that's what I'm going to go over. Now for question 1, I've got sine x over tan x equals cos x. Now important thing just to keep in mind quickly before we begin. Say for instance, I had a fraction like this. Actually, let's make that something which doesn't go in. Let's have... over 3 like that. So I've got 5 over 2 over 3. When I've got like a triple layer like that on the fraction, the third one down actually comes up to the top and multiplies with it. So we're going to have to use this idea in this question here. So looking at that, the fact I can see a tan there means I'm instantly going to use that tan x equals sine x over cos x. So putting that into that expression there, what I'm going to start off with I'm going to write left-hand side, and I'm going to write out what the left-hand side is again. Then I'm going to swap out the tan x for the fraction. So I've got the sin x over sin x over cos x. Then I know that that cos x is going to come up to the top there and multiply with the sin x. So I've got sin x times cos x all over sin x. Those sin x's are going to cancel each other out. And so all I'm left with is that cos x. And that is equal to my right-hand side. So I've kind of put the point of writing left-hand side all the way down to the right-hand side because I'm showing that I've gone from one side on my equation to the other. So that's the one minor difference with these types of questions. So let's take a look at this next one here then. So I've got 1 minus cos squared x over cos squared x equals tan squared x. So the one thing to keep in mind here, this tan part is on the right hand side. So typically we're not going to start on that side. We're actually going to start on this left hand side here. So we're going to start on that side. So one of the things which we can do here, because I'm dealing with a lot of these cos squared x and the sin squared x, that means I'm probably going to be using this identity here with the sin squared x plus cos squared x equals 1. Now there's a few ways I can go about using this identity. I could show my rearranging for it and putting it in that cos squared x part, but I'm actually going to go through a slightly different route. I'm going to swap out the 1 for the sin squared x plus cos squared x. And then I have that minus cos squared x from before. And then what's going to occur here, those are just going to cancel each other out. So I now have the sin squared x over cos squared x, and then using my knowledge of the tan x equals sin x over cos x, that can get me to that last step. So this is one of the ones where I'm actually having to use both of my equations, both of my identities, and that gets me to my right hand side. So they're a little bit weird, these identities, but the key thing is just trying to look out for which identity you're going to use and write it down and just try and do something with it. So again, if 9 times out of 10, if there's a fraction, if there's the word tan, you are most likely going to be using that tan x one. However, in all the other occasions, it's that sin squared x plus cos squared x one. So let me know if you have any questions and good luck with the work.